Maths educational video. Multiple integrals over general domains. So far we have learned how to compute a double integral over a rectangular domain. It's time to generalize. A rectangular domain is bounded by 4 lines. 2 vertical lines, x equals to a, x equals to b, and 2 horizontal lines, y equals to c, y equals to d. One way to generalize this domain is to replace the horizontal lines with curves. Call them y equals to gx, y equals to hx. Such a domain is known as a type 1 domain or type 1 region. Another way is to replace the vertical lines with curves. If you call them x equals to g of y, x equals to h of y. Then this region will be bounded between 2 horizontal lines and between 2 curves, one lying entirely to the right of the other. Such a region is known as a type 2 region. Let's look at how we can compute the double integral. The formula is given in the box. We'll integrate the function with respect to y over the functions g and h, followed by integration with respect to x over the numbers a and b. It's possible for the two curves to intersect, either along x equals to a or along x equals to b, or both. All these are considered type 1 regions. Just a reminder how we compute double integral. We'll always calculate the inner integral. Integrating a function of xy with respect to y will give us a function of x. When it comes to type 2 domain, the formula is given in the box. This time we have to integrate f with respect to x over the functions g and h, followed by integration with respect to y over the numbers c and d. Again, it's possible for the curves to intersect. All these are considered type 2 domains. And finally, as before, we always perform inner integration first. Integrating the function f with respect to x will give us a function of y. Let me show you a numerical example. We are asked to find the integral of xy squared with respect to xy over a domain D, described as follows. D must lie in the first quadrant, and it must be bounded by 2 curves. So the first step is to draw the region D. And we find the intersection by solving the simultaneous equations. Inspecting the region D, we realize that the region D is actually a type 1 region. It's a type 1 region because it lies between 2 vertical lines, x equals to 0, which is the y-axis, x equals to 1. And between these 2 vertical lines, the region is bounded between 2 curves, one lying entirely above the other. The one in red above the one in green. So it qualifies to be a type 1 region. So the formula is given in the box. We will now integrate the function with respect to y first. Notice that x is actually a constant with respect to y. So obviously the next step is to move x out of the integral. And we integrate y squared with respect to y. That's pretty easy. It will give us y cubed divided by 3. And we substitute the integration limits to get a function of x. And further integration will give us the final answer of 5 over 77. Interestingly, the region D is also a type 2 region. It's a type 2 region because the region is bounded between 2 horizontal lines, y equals to 0 and y equals to 1. And between these 2 horizontal lines, we see a curve lying entirely to the right of another curve. We rewrite the equation in the form x equals to a function of y. So y to the power of 1/3 is a larger function. X equals to y squared is a smaller one. We integrate the inner integral with respect to x. This time y squared becomes a constant. So we transfer y squared out of the integral. Integrating x gives x squared over 2. And finally we get the same answer, which is what we expect.